Yeah, g'day YouTubers. Tinker O'Toole again here with another video. Today we're going to talk about Rakers Drags. But before we get right into that, let's go back into history before chainsaws were even invented. And they had drags and rakers back in those days. And we'll see how that transpired into modern chainsaws. Now, typically saws go back hundreds and hundreds of years ago with the teeth on them. And as time went on, they discovered that if you had drags or rakers, but we'll talk about drags first, typically drags, I think the name, it's very hard to find precise information because different conflicting theories out there. But the information that I sort of gathered that the word drags came about after they were using drag saws. And that meant they're cross-cut saws, but you had a guy at each end and they used to drag it from side to side because you would pull it towards you and the pulling motion, like as if you're dragging something. So the information that I got is drag saws, and then eventually with motorized motors came along, electric motors, and also your two-strokes and that. They were motorized drag saws. You had portable motorized drag saws, which still had, and we'll pop a little slide up here of some very early chainsaws. And if you have a look, it's typically an old cross-cut saw. And we can keep on putting some pictures up as we talk. And typically those cross-cut saws were fairly long, about 6 foot in length. Some were longer, some were a bit shorter. Just depends what they were cutting. And most of the time they had a series of teeth. They had very sharp little cutting teeth. And at either end they had the drags or the rakers. And they stuck up, they stuck a little bit below the teeth so that the teeth wouldn't bite in too deeply. And they were a totally different shape. And we'll put a slide up now of where you can actually see the teeth, a different type of teeth, what the drags were. So that's what drags were, or rakers. Now, the other thing is, and I'm still not 100% sure on the drags 100%, but it could also refer to dragging the sawdust out. Certainly the rakers got their name from raking the sawdust out, because that's what they were designed to do. Because with those little cutters that were in there, they were long. If you look at the picture, you can see that they were long and they had very sharp teeth on them, like an eye tooth, except they were sharp at each end. And they would cut into the timber, and the raker would rake and sever small fibres, as well as drag all the sawdust out at each end as it was going backwards and forwards. And this motion depends on how fast that you would go. You could do up to 1 metre a second of speed, whereas modern chainsaws, you're doing 35, 40 metres a second. Big difference in speed. So that's what they were called back in those days, and people still predominantly call them drags or rakers. I call them rakers. And some people even call them raker gauges, where the actual raker gauge is generally the tool to measure the depth, or depth gauges is another one that they call them. But I refer to this as a raker gauge tool or a depth gauge tool. Now, it's interesting when we talk about these little flat ones here. These flat type gauges were invented by Joseph Burford Cox, amongst many other things. That Joseph Burford Cox was well known for inventing the Cox chipper chain, as well as the full chisel. So he invented this, but his version was a little bit different. It was 25 thou on one end and 30 thou on the other end. Now, the other thing that's very, very interesting, and nobody's ever made a gauge, a constant flat gauge. The reason that we refer to this as a constant flat gauge is because you can see where it says 0.65. That means that you can see that lower section there, when it sits on a tooth, it's going to keep a differential between the height of the tooth and the height of the raker at 0.65 of a millimetre from brand new to the end of life, which is not the ideal scenario. There's also another thing that this type of gauge doesn't do that could be changed. It sits dead flat, all right? So, yeah, it just sits dead flat. Now, they could have had this gauge designed so that this part was on an angle, right? Had they had this part on an angle, it would have been a much better gauge, because using that type of gauge, all you're going to do is file the raker dead flat. And we all know that the rakers aren't dead flat. If we look at an original tooth here, you can see that curve on it, like a ski jump, right? And the whole idea of that is to reduce vibration and to have a smooth transition as the raker hits the timber, that it's not a sudden impact, it's a gradual rise. So this type of gauge, after you file the rakers down a little bit, you're going to file them flat because of the way this gauge is designed. And as I mentioned, had this gauge been designed where it went down on an angle, things would have been a little bit better in that department. But not all hope was lost, because a man by the name of Ray Carlton brought out and put a patent on the progressive depth gauge in the early 60s. Now, I don't have one here. He called it, we could put a slide up there, he called it file O-plate. And all the pro loggers were using it because they found out that it performed much better than Joseph Cox's gauge. This type of gauge is okay when the chain is brand new, but after a few sharpenings, you really should be using a progressive depth gauge. And we'll just talk about the progressive depth gauge. I've got 3 here, progressive depth gauges here. Well, I've got 4 there. There's a still one. We'll just talk about the still one. That's the still one there. 2 little windows. It looks like a Lego man. That's what it looks like, except no arms on it. It's placed over the top of the tooth, and you can see up the top it's got HA, the RD's been filed off, and SOFT for soft timber, so a hard and soft setting. And it sits on a tooth at about that angle, right? And the raker protrudes out of that little tiny square window, and you leave it in place and run the file over the top. Pretty simple, straightforward to use. So that's how it works, and it does a much better job. The way that it actually works is as you file the tooth back, whether you file it back or grind it back, this angle starts to get a little bit lower because of the tooth. If you have a look at a chainsaw tooth, they're on an angle, about 10, 12 degrees sloping angle on the top. So as the gauge sits on here and we file it back, it moves down on an angle, the raker protrudes, and you can file that off on an angle. Also, by using this type of gauge, because you're filing on an angle like that, remember before I spoke about this gauge that you file flat? Well, filing on an angle is a bit of a ski slope. So you've got a much better, smoother transition. So the filer plate was discontinued after Blount got acquisition, I think in the early 80s, of Oregon. I think it was somewhere around, could have been even around the 90s. But anyway, Blount took acquisition as well as they took acquisition of Carlton. So Blount International own both those companies at the moment, and they discontinued the Filo plate. However, if you look on eBay, there's a few floating around that are still brand new because there was a large stockpile of them in shops and that, and people are selling them for a good price, and brilliant gauge. Now, there was a company in America called West Coast Saws, and they started to manufacture their own, which looked identical almost to Carlton's one. All the patents are gone on these gauges, so anyone can make any gauge they want and call it whatever they want. Okay, so Husqvarna have had this progressive depth gauge out before, still had theirs. And there's different versions. One of the most common that a lot of people use is this type here. Essentially, it's identical to the Stihl one. It works on the same principle, whereas this part here with the cutout sits on the tie straps. This part here, the raker protrudes, and underneath the tooth sits about here. So it sits on top, and you've got a hard and a soft setting. This is fairly common, and because you're running the file over the top, these tend to last for many, many years before they get worn out and you'd have to discard them. Now, Husqvarna also sell these type as well. They're a roller, so that you sit that over your chain and you can file at 30 degrees. That way you know you're at 30 degrees. So that's what they are. This one, you can see it says use a 5.5 millimeter file. This is for specific chains. On the other side, 732. And Husqvarna have got this for X-cut. So this particular gauge here is for C83 and C85 X-cut. So Husqvarna have a huge range of these. So that's that type there. This is another type they've got. This is probably a bit of an older style, but it's just exactly the same principle and everything else. And it's for, if we have a look there on the bottom, it's for 3.8, 5.5 file, H51, H54. The other ones, a bit hard to read that. I'm just trying to read that at the moment. H58, yeah. So most of these gauges will fit a few different chains. As I said, in the Stihl, so if you look at the Stihl range, you've got 5 of these for the 5 different sizes. FL1 for 1/4 inch, FL2 for 3/8 low profile, FL3 for 0.325, FL4 for 3/8 standard, and FL5 for 404 chain. And all of these gauges are held at an angle, so you will get the nice ski slope rather than the flat type raker like that. Now, the other thing that's worth pointing out about these particular gauges, because I've got virtually every progressive depth gauge that was ever made, a bit of a collector. One thing about these, the difference is that when you get to the end of the life, rather than have a gap of 0.65 of a millimetre like this one is, you'll end up with about 1.3 millimetres difference. So, and that's progressive. So if a brand new chain is 0.65 of a millimetre approximately, which it is using this gauge, by the time you get down to the end of the life, the witness mark, you'll have a gap of about 1.3 millimetres. One of the main reasons that you need to increase that depth is because the distance between the tooth and the raker, the distance between the tooth and the raker here when brand new is about 6 millimetres on a 3/8 chain. By the time you get down to here, it's doubled the length. So therefore the rocking motion is a little bit different, and it needs that extra depth to take out the same size chip. Also, the other thing you'll notice, that this is where the rivet is, and this is where it pivots, and we're well in front of the pivot point here. But by the time we file this back down here, we're behind the pivot point. So the rocking motion sensitivity is totally different between a brand new chain and a older chain. And that's one of the reasons that the progressive depth gauge was invented, so that it gives you the right depth to maintain your cutting efficiency. And your cutting efficiency, for those that are familiar with woodwork geometry, when we talk about attack angle, the attack angle of a standard chain would be just under 5. And what that actually means, that if you're to measure the angle of the raker and the tooth, it needs to remain at that angle of about 5 degrees from brand new to the end of life. Whereas what tends to happen on this type of gauge, the attack angle will start to diminish and get even as low as 3 degrees. So brand new, around 5 degrees, using this gauge, but at the end of life, your attack angle will decrease to about 3 degrees. On the progressive depth gauge, your attack angle is going to remain constant all the way through. And that means to maintain that attack angle, you need to take off more than 0.65 of a millimetre. So it really does work well. You'll get 100% cutting efficiency. As you file the tooth or grind the tooth down, also another thing that happens that you may not be aware of is because you're removing more metal and not just off one tooth, when you remove all the metal off all the teeth, chip clearance works much better because you can pack more sawdust where the filed material's been removed. So that works really good, chip evacuation. And the other thing that happens, that if you ever look on top of a tooth, you'll notice there's a taper. It's much thicker right at this point here, and it's much thinner down here. So the other thing that happens, that as your chain starts to wear down, the kerf gets smaller. And by the kerf getting smaller, the cutting efficiency, there'll be less strain on your saw, and you'll find out that because of those two reasons, a reduction of metal in the tooth gives you more room for the sawdust and improves chip evacuation, and a slightly narrower kerf will take less strain and horsepower off the saw and can also improve cutting performance. So a chain that was brand new that's half worn can actually outperform a brand new chain if you file it and you use a proper progressive depth gauge. So look, I hope that information helps. It was a bit of a blast from the past when you talk about drags and rakers. And you look at those saws in some of those pictures, and you could see how someone was smart enough. Joseph Cox was very, very smart man when he invented the chainsaw chain. There were a lot of other people in that era, in the even going back in the late 40s, 1948. There's a whole bunch of people working on chainsaw chains and coming up with all different, there was lots of patents put out there, right? And there was lots of designs that weren't patent, but Joseph Cox was the first person to get it to the patent office. So another chain that we didn't sort of discuss is a scratcher chain. We'll just put a bit of a slide up there. Totally different chain. It's like one tooth in front of another tooth, and you've got one tooth in the middle which acts as a raker, so it sets the depth. And they were before Joseph Cox invented the Cox chipper chain. So if we look at modern chainsaw chains now, and rakers or drags as we still call them, what's their job and function today apart from setting the height? Do they help rake or drag out the chips? Well, the thing is, what you've got to remember is that back in the day when they were using the drag saws, they were going very slow. Whereas these days they're travelling over 100 kilometres an hour. So the chain and the teeth are just zooming past. So when a tooth digs out a chip, the chip may be momentarily just sitting on the, or it's just come out, and the chain passes so fast that the chip goes underneath the top plate where possible. Comes out the back as the chain races over the top of it. So it doesn't come out of the back by force, it comes out of the back because the chain overtakes the chip because of the high speed. In a microsecond, with thousands of other chips, they all get pushed forward like a snow plough pushing forwards. So because of that forward motion at 100 kilometres an hour, all the chips get caught up in that forward motion and go forward. So every piece of metal that's there, the raker included, the top plate, the side plate, every bit of metal, even the tie straps, every bit of metal there pushes the chips to a certain extent. So that's the way that it works. And the other thing is, with these progressive depth gauges, you've got the two settings, the hard and soft setting for the different woods. So progressive depth gauges give you that option, whereas a constant depth gauge only has one setting. The funny thing is, when Joseph Cox made that dual gauge, which was 30 thou on one end and 25 thou on the other, Oregon still don't even sell that. Blount must have discontinued that gauge as well. So if you use a constant depth gauge, the other thing I was talking about before, that when you run the file over a constant depth gauge, which is this type here, there's no downward slope, because they didn't make the gauge with a downward slope. They could have, but they didn't. So the way that you get out of that is that you should file the end of the tooth so that it's rounded corner, and that will help as well. A smoother transition to reduce also vibration, and also so that you don't get as much jerkiness as the depth gauge runs over the wood. Look, I hope that information helps. It was a bit of a blast from the past. You can call them rakers or drags, whatever you want to call them. They are a limiter, and they limit the amount that the tooth bites into the timber. So yeah, you can call them, there's many different names for them, but predominantly they're either called rakers and drags, depends when you were brought up in what era as to what you refer them to. As I say, some people call them depth gauges as well. Anyway, I hope that information helps. Just make sure that you do keep your rakers at the correct depth, because if you do, you'll find out your cutting efficiency will always be maintained at 100% or as best as possible, provided that you keep the rakers at the correct depth. And if possible, do yourself a favour, go down to your local steel shop or Husqvarna or West Coast Saws over in America. Do yourself a favour and get yourself a progressive depth gauge. You'll thank me for it. Thanks for watching. Bye for now.